Hello everyone. In this video I'm going to solve packet tracer activity examine the ARP table from chapter 9 CCNA version 7 Introduction to Networks. Let's see the objectives. First we will examine the ARP request, and then we will examine a switch MAC address table, and then we will examine the ARP process in a remote communications. So what we will do in this video, we will check the IRP in the PCs, and then we will check the IRP table in the switches, and then we will check the IRP table in the router. So background, this activity is optimized for viewing the protocol data units. The devices are already configured. You will gather PDU information in simulation mode and answer the series of questions about the data you collect. In part 1, we will examine the ARP request. So first, we will generate ARP request by pinging the 172.16.31.3 from 172.16.31.2. So we will go here, and then we will go to the command prompt, and then we type IRP -D to delete the old or any MAC table in the device. To make sure we deleted it, so we type -I to list all the IRP table, and you can see currently we have no entries in the IRP table. Then enter simulation mode and enter the command ping 172.16.31.3. 2 PD will be generated. The ping command cannot complete the ICMP packet without knowing the MAC address of the destination. So the computer sends the IRP broadcast frame to find the MAC address of the destination. Okay, we will try to ping the device 172.16.31.3. We will try to ping this, and we will do this in the simulation mode. Do it like this, then. So we would like to ping this device from this device, but in this device currently there is no MAC addresses. So to reach this, to do this, we will see how the device will generate an IRP request message. So ping 172.16.31.3. As you can see here, two packets generated. The first one is ICMP, the second one is IRP. And then click capture and forward once. The IRP PDU moves switch 1 while the ICMP PDU disappears. Waiting for the IRP reply, open the PDU and record the destination MAC address. So when we click forward once, we will see the ICMP will disappear because it will hold on, it will wait the IRP request to bring back the MAC address of the PC 172.16.31.3. Let's see. Okay, and here the device forwarded the packet or IRP request to the switch. And let's see what is the MAC address, or where is the destination MAC address. As you can see here, the destination MAC address is this one. This is the broadcast address. What we also have to do, so we record the destination. Is there is address list in the table above? As we can see here, no, this address is not listed in the table above. This address FFF, it is not here because this is a special address. This is a broadcast address. Okay, where we will continue reading. We will see what we need to do more. How many copies of the video did switch 1 make? So we'll move once, as you can see here, because it was a IRP request with a special destination MAC address. The switch will forward the request to all the ports except the one it came from. So we'll generate here. You can see 4 ports. The IRP request arrived from here, so the switch will generate 3 copies or 3 copies from this request and send to the ports except the one it came from. Okay, how many copies of the PTU did switch 1 make? 3. What is the IP address of the device that accepted the PTU? So the IP address of this device is 172.16.31.3, and because this is the IP address that we tried to ping. So here we open PTU and then we try to see what happened to the source address here. So the source address, this here, it was the source became the destination MAC address, and this special address turned to the MAC address of the BC 172.16.31.3. And then we have how many copies of BDU did the switch make during the ARP replay. We will see only 1 copy, as you can see here. The switch generated only 1 copy. Do the MAC address. So we will open the video and we will examine the MAC address here. And here we have do the MAC address of the source and destination align with their IP addresses. So what we have here, yes, as you can see here, we have here the MAC address and here we have the IP addresses. And then we need to switch again to real time and the ping completes. So we will go to real time. You can see here the ping completes. And then we go to click 172.16.31.2. We are here already. And then we will enter now IRP -A to see the IRP type MAC address. And you can see here we have now 1 entry in the MAC address type. In general, when does an end device issue an IRP request? So when the device doesn't know the receiver's MAC address, when there is a need to send a packet or a frame to the device and the sender doesn't know the MAC address of the destination, the sender issues the IRP request. Now we have part 2, examine a switch MAC address table. So we will close this. Now we will read what we have to do. Generate additional traffic to populate the switch MAC address table from 172.16.31.2. Yes, we enter the ping to 172.16.31.4. So from here we need to ping this one. We will try to ping this one, 4, and we can see the ping is successfully finished. And then you click the 10.10.10.2 and open the command prompt. we have go here now, and then we open the command prompt, and then enter ping 10.10.10.3, and how many replies were sent and received. As you can see, 1, 2, 3, 4. So we need to examine the MAC address table on the switches. Click the switch 1 and click CLI tab, and then enter the show MAC address table. Go here, CLI, we go to the enable mode, then here we type show MAC address table. Do the entries correspond to the table above? Let's see. We have first port 3. This is the MAC address. Yes. Port 1. This is the MAC address. Yes. Port 2. This is the MAC address. Yes. And Gigabit Ethernet 01. This is the MAC address. Okay. So yes, it is. It matches the same. Let's continue with this, and then click switch 0, then CLI, and then issue the MAC address table again. We will repeat the same process here. Enable show MAC address table, and we will see what we will have here. We have Gigabit Ethernet 01, we have Gigabit Ethernet 02, we have Gigabit Ethernet 02, and we can see here we have two MAC addresses to the same port. Why? Because the two devices connecting to the same port using the access point. Let's see what will happen. Do the entries corresponding to the to those in the table above. Let's see. We have router 0 and we have switch 0. F02 we have here, and yes, F02 here, and Gigabit Ethernet with 0, this one here. So yes, it is. Why are two MAC addresses associated with one port? Because two devices connected to the same port using the access point. And now we will continue with part 3. In this part we will examine the ARP process in the remote communication. So first we will generate traffic also again. So we will generate traffic from, we will ping this device from this device. We will see what will happen. We will open this, and then we will try to ping 10.10.10.1, and then type ARP-A to see the MAC address table and the device. And what is the IP address of the new IRB table? So we already have this. We already have this. So this is the new one here, because this IP address of this device, this IP address of this device, along with its MAC addresses, or with its MAC address, and here we have the new one, or the new entry. Then let's try to delete. Let's delete the this table. So IRP as D. We make sure it's deleted. Yes, and then we will switch again to the simulation mode. And then we will repeat the process. From here we need to ping, and you can see two packets of PDU generated. So how many PTUs appear? 2. Click forward, capture forward, click the PTU that is now on the switch 1. So we do this. We click flash forward and then we check the BTU here in the switch 1. What is the target destination IP address of the ARP request? So as you can see, the destination IP address is this 192.16.31.3. So here where the destination IP address is not 10.10.10.1, yes, because this is the IP address of the default gateway. So as we know, when we would like to ping or we'd like to send packets to the device on a remote network, the sender usually sends the packets to the default gateway or to this IP address of this port. So here now we have to examine the IRB table on the router 1. So switch to real-time mode, and then let's see the ping. And on router 1, click command line interface. And here what we have to do again, then enter privilege mode and show MAC address table. Then print and command enter. By the way, this is not the correct way because this is totally different here. When you use this command in the switch, it means that we would like to check the MAC address table, but in the computer is totally different. How many MAC addresses are in the table and why? We have 0 MAC addresses because this command is totally different in the switch. So when you issue this command in the switch, you get the MAC address table, but here in the router is totally different. It means something else. So if you would like to check the IRP or to check the MAC address of inside the router, you should issue the command show IRP. As you can see here we have the MAC address table inside the router. So here we enter the show IRB command. Is there any entry for 172.16.31 true? Yes, we have this one. And then what happens to the first ping in the situation where the router responds to IRB request? It was timeout, as you could check. This is the end of this video. We checked how to examine the IRP in a PC, in a switch, or in a router.